so check our aim. Our aims today are. Oh, we want to read it? Yeah. Voices off. Show me hands. Shania, go. Loud and proud.
Identify key vocabulary terms for motion and design.
Motion and
design.
Our last unit one was electric what?
Circuit.
We're now on motion and design. So I need to figure out what you all know. I need you to prove to me what you know about motion and
design.
I love how you sit in the start. I love how Eden is tracking. I love how Cheyenne is tracking. So if you are Andre, Ariana, Nicholas, Jamela, Shadrach, Callistus, Cheyenne, Shania, Chelsea, and Andre, get your papers, go. I'm looking for your names to be on the sheet. I'm looking for your first and last name. First and
last name.
First last name. I'm looking for the first ones ready because our voices are off and we're just writing right now. Our first and
last name.
On our first sheet, on the top sheet with the vocabulary words. Callistus is there. He wants that admit one. Ariana's there. She wants that admit one ticket. Chelsea's there now. Shawnee. Oh, both of you guys are ready. In a loud and proud voice, Aiden, I want you. In a loud, no, don't track him yet. Track me. In a loud and proud voice, I want you to read our directions. But before we go there, track our agenda. Today we're going to go over our vocabulary that we've already learned in motion and design. And then we're going to talk about something that you all spoke about. I have Ayo's eyes. I have Iman's eyes. I have Nayenda's eyes. I want to talk about that weighted string. Remember, you guys talked about a weighted string? But I want to emphasize that a little bit more. And then we're going to go into our new lab manuals. I want us to go into these new lab manuals and make sure they are the bomb. I want them to be great. Because we have practice during electric what?
Circuit.
So we know exactly how to set up our lab what?
Manual.
Then we're going to go into learning from butterflies. You'll see what that's all about. So as soon as you're done with our activity for vocabulary, show me start. You're going to go directly into your article. Highlight 5 things that stand out to you. First, your vocabulary. Directions, loud and proud, Aiden, go. Track your directions.
Write a definition for each of the scientific terms listed below in your own words, and draw an image that helps you remember the word.
If your hands are not in star right now, that means you don't know what an image is. No, if your hands are in star, I know you know what an image is. That's the only way I know. Show me star. So I need you to write a definition in your own words for each of the vocabulary words. Tracking me. For each of the vocabulary words, and also add an image. Add a what?
Image.
Add an image that helps you remember exactly what that word means. So for instance, if I had a word friction, I'll say friction. I know it's like rubbing 2 objects together, sometimes causing static what?
Electricity.
Nice. So then my image would be that image that Mr. Allen always asks us to do. So whenever we talk about friction, we do what with our hands?
Rubber.
Oh.
Nice. Jack is off. Wood will create fire with that static electricity. So let's go. I'm going to give you 15 minutes on the clock. I'm going to be coming around. So first, we do our vocabulary, your definition, and your what?
Image.
Thank you. Your definition and your image. Immediately after that, you're going to raise your hand. You're going to raise a vertical hand. I'll pick that up. You're going to start your article. You're going to give me how many things underlined?
5.
Ready? Pencils up. Okay. Set. Thank you, sir. I want everyone to get a fair start. I will get it. I'm listening to voices off. Set. Start. We're first starting with vocabulary, back and front. You're going to raise your hand, then you immediately start your article when I pick it up. Right? This first. Try your best. I should see names on everyone's page because we're starting with the vocabulary first. Nicholas, yes? 2 minutes. You guys know Mr. Allen likes your work nice and what? Neat. Remember that as your drawing. I like how some of our scholars have their first and last name so I can know exactly who they are. We didn't say picture, we said what word? Image. Nice. Just make sure it's clear for me to really understand exactly what it is. Yeah, that's an image.
And
Another name for an image is a picture, no?
oh, and what is when like you open the front of the car like is like a trunk but
Hood.
Oh, a hood.
Keep right. Hands on your desk. Focus. Bring your chair. Bring your chair. Thank you. I love how Shawnee is working. I love how Nicholas is working. Aiden is working. He's writing ferociously. How's Aiden writing?
Ferociously.
Thank you, Naomi. Sean. I see some very interesting images. Quickly. Okay. As you're writing, keep writing. As you're writing, keep writing. If you're having problems with the definitions, remember, look at the word. When was it used? How did we use the word? Is it an object that we've used? What did we do with the object? Think that way. So all of our feet are flat on the floor, and we are focused on our work. Scientists, you have 10 minutes. Keep writing. I know Suni needed the entire 15 minutes, but I know Howard doesn't. I know you all are going to show me some work very shortly. Keep up. Flip the page. That was a little surprise. I haven't seen you guys in a couple of days. So we're still working on our vocabulary. We are not concerned about our lab menus right now. Cheyenne, keep working. What that word means, what it means, and then draw a picture that helps you remember what that word means or does. Nicholas, finish that page, and then you can go, okay? You guys are working very good right now. I like the nice and neat work I'm seeing. The very vivid images that you guys are sketching. You ready? Both pages. Look on the back. Surprise, Mr. Alice back. Of course. That's when you give a second grade or a third grade, but we're in fourth grade, so of course we're not going to do this 5 vocabulary. Let's keep working. Okay, Chuck. Chuck. You good? No, don't rush your image. You shall pride in the work that you give your teacher. Yes. You ready?
Do you know a bike might be aquatic vehicle?
Yeah, it can be.
We'll
talk about it.
I said
I'm at 5. Yes. Remember, we spoke about aerodynamic, terrestrial, and what?
aquatic.
Okay, so I'm going to act like you guys know some science, because I know you guys are all scientists. So we spoke about terrestrial, aquatic, and what? Pause. Put your pencils down. Show me start. Aiden's there. Cheyenne's there. Io and Schneider's there. I'm waiting for 1, 2. We spoke about 3 different levels where vehicles may roam or may be operated. The first one was aerodynamic. We said aerodynamic. And that meant it was up in the air. Check it, are you sure?
Yes.
Shall we start? I have Jamel's eyes, they're glued to me. Callista's eyes are glued to me. Then we said terrestrial. Terrestrial are vehicles operating on land. Okay, and then this last thing, I think it was called Aquaman?
No.
Okay. Maybe it's called aquatic?
Yes.
Aquatic deals with what?
Water.
Who disagrees? You disagree that aquatic deals with water? Aquarium, someone said aquarium. So I'm at 5. You're going to begin working. Get ready. You have 6 minutes. Set. Go. So I take your vocabulary, then you go straight to your article. You go to 5 pages. After the question. Remember that blue page we had up there? Don't forget about that. Thank you. Good work. I have 1. I'm waiting for someone else. I feel like lonely. I only have 1 page. Some of your voice needs to be off right now. Again. 5 minutes. exactly so your voice is off and you can keep reading, okay? I'm coming around. Collect it out. Collect it out. And you ready? Go to your article. Rip it off. Let's keep up the good work. Let's keep our voices up and focus. Callistus, you know what we should be doing right now. Kareem? Thank you, buddy.
Can I get another piece of paper? Because I want to paraphrase all in my own words.
You want
5 things.
How about you take notes exactly in the area that you want to paraphrase, okay? And make sure you put your name on it. Keep going. Keep working. Keep it at the same place. Sit up. You'll be all right. And start with the image. And then you can think about the definition.
What does this mean?
1 second. Yes. Use context clues.
Is the word for.
To and from. To and from. To and from. You done? You just keep it going, okay, buddy? Okay, Angelique is almost ready, so I won't be alone anymore. Good. Go. Sean, yeah? I want you to try your best, and then I'll correct you later, okay? Try your best with your spelling. Yes? You ready for the article? Here we go. Yes? Question. Yeah? You ready? Article. What did you need?
Article.
You don't have one attached?
Oh, yeah.
Okay. Let's keep going, buddy. Catch up. All right, Howard University, you have 3 minutes remaining. Let's go. When you hear the buzzer, I want you to immediately go to your article. I want you to immediately go where?
To your article.
Thank you. So that means Nicholas is going to keep writing right now. Thank you. And Andre is still writing. Get to that next page, then I'll article. We don't need our lab manuals right now. Article. Get to work. Start with the image. Think of an image, and now maybe help you find the definition. There we go. Yes. Preview drawing. We had this big blue thing up here.
It's a blueprint.
Ooh. So, in about 45 seconds, everyone should be reading the article. So I'm going to get my marker and come around and mark your vocabulary. Sharon, keep going. Today's color is blue. 54 seconds. So I should see people turning, young people, scholars, turning. Where are you going? I didn't tell you to go yet. You finished it? You're not finished. 120 seconds, buddy. Chelsea's already turning her page, her article, so she knows what's going on. Janae's there, right? Start turning. Article. Start the article. Do those great things that doesn't get you on the board. Cool. All right. I'm going to see who's going to respond. Green just got there, and he knew what to do. Thank you, Nicholas. Hunter, you hear this buzzer. In the Loud and Proud voice, I need Callistus. I need Callistus to read the title of our article. Go.
Learning from butterflies.
Learning from what?
Butterflies.
If you can track the side of the first page of your article and read along with me, it says, oh, wait. Who's not there? Because everyone's hand should be in star at this point, where the page is flat. On the left side, it says, have you ever watched butterflies fluttering to and fro? Their flight may look random or disorganized. They may even, your voice is off. They may even look, what's that word?
Clumsy.
Your hand should be on your desk. You should be in star at this point. No more highlighting. But a recent research conducted at Oxford University in England suggests that this is not what? This is not what? Let's just start reading. Scientists
Scientists at Oxford came up with a method studying the free flight of butterflies.
They said the free what?
Flight.
Of butterflies. But that ties into Andres. That ties into something we did 2 weeks ago. Something about a system, also known as a, what's your name? A free-falling weight what?
System.
Keep going, Callistus, go.
They trained red.
Pause.
I
Pause. Not tracking your article. Not tracking your article. Andre, where are we in this article? Which word?
They train.
Excuse me?
They train.
Let's go. Continue, Callistus.
They trained red admiral butterflies to fly between artificial flowers in a wind tunnel.
Red Admiral butterflies. Wait, I'll go, then you go. Red Admiral butterflies, go.
Red admiral butterflies.
Continue, Kareem.
They took pictures of the butterflies in flight. To visualize how the butterflies move, the scientists smoke into the wind tunnel as a way to attract the butterflies.
Pause. Show me start. Let's get ready for a demo. A demonstration. Pay attention. I'm going to reread something that Kareem read. And it says, they took pictures of the butterflies in what?
Light.
To visualize how the butterflies move, the scientists pumped smoke into the wind tunnel as a way to track the butterflies as what?
Movement.
So, let's put on our imagination caps. Nice. Show me stuff. Bless you.
Bless you.
Thank you. Show me stuff. That's quite bad. I'm in the wind tunnel. Picture a wind tunnel. It's kind of dark, but we have like this little flash of light because we created light bulbs and electric circuits, did we not?
Yeah.
All right, so we work with light bulbs and we work with wiring. So we have a small dose of light in our wind tunnel. So we pumped it with what?
Smoke.
We pumped our wind tunnel with smoke. So think about it. Why would scientists, I'm looking for a super duper smart scientific answer. I'm gonna try that again. A super duper smart scientific what?
Answer!
About this. I have Nicholas's eyes. So that means he's ready to learn. Aiden. We pump the wind tunnel with what?
Smoke!
We pump the wind tunnel with smoke. Why would a scientist, why would a group of scientists want to use smoke to track the movement of a butterfly? Aiden's hand went up first, so we're tracking who? Let's see who's not tracking, because we all should be. Let's go.
I think that the scientists put smoke so when the butterflies go into flight, they could see the wind stroke.
Oh, nice. He said when what?
Stroke!
I need a super duper scientific answer from someone using a having of discussion. Show me hands. No one's brave? No one's a scientist in here? Come on, we've been doing this for months now. I want to see Jamela. Track who?
Jamela!
Three guys, let's see.
I agree with,
Oh, I can't hear you. Loud and proud, please.
I agree with Avery because since we could see smoke, when the air pushes the smoke, we can see the action.
She said when the air, because we learned about air resistance, we learned about air what?
Resistance!
And so we know the movement, show me the movement, the fluttering movement of a butterfly. Okay, back to stuff. So with those wind strokes, they're able to calculate and see based on the movement of the what that was pumped into the tunnel.
Smoke!
Speak to me, guys. What was pumped into the tunnel?
Smoke!
Right. So the movement of the smoke shows the direction of the what?
Tunnel!
Try this. Great. Continue reading. Go. The scientists found.
The scientists found that big movement creates colorful spinning air called vortices.
That's a good reader right there. He said vortices. He said what?
Vortices!
That's the plural meaning more than one for, what word do we hear in vortices? Try it, come on. Angelique? Vortex. Say vortex with me.
Vortex!
Remember we talked about systems. And we talked in mathematics as well. Shall we start real quick? We talked about these systems, Andre, sit up. That they can be something that we build and touch, or things that we can't see. Remember when we made our free-falling weight what?
System!
All I did was get a ball. We had its constant, which was point A and point B, right? And then what did I do with the ball in our free-falling weight system?
Nothing!
But how do we calculate the speed of the ball dropping, Nyanda? With the timer, but we called it something else. We called it a what?
Millisecond!
Milliseconds. We calculated in milliseconds, but the name of the device we used was called a what?
Stopwatch!
I need, in a loud and proud voice, Shania to continue reading.
The experiment of
Pause. I'm just waiting for everyone to track their page and not Shania. You guys are doing excellent right now. I'm looking at Cheyenne. Thank you. Let's go.
The experiment also showed that the familiar looking butterfly is caused by a
Methods. Say methods. Go.
Methods!
Methods. So remember again. Think about methods. Think about troubleshooting. We found different methods to solve the what?
Problem!
I'm going to say that again. Troubleshoot. We found different methods to solve the what?
Problem!
Troubleshooting is what?
Finding the problem!
Different methods to solve the.
Problem!
We're tracking our article. We're tracking our article. Continue, Schneider.
But butterfly used as they take off maneuver
I'm maneuvering through the classroom right now. Track me. I'm maneuvering through the classroom. I'm maneuvering through the classroom, Callistus. Can you tell me what maneuvering means? To move. Keep going.
And maintain steady flow.
Nayenda, loud and proud. Continue. The
The
smoke.
smoke helps scientists follow the ring strokes at the bottom. The horizontal ring in the middle of the image was produced by a previous downstream. The bottom image shows the vertex breaking up because the butterfly's wings are at the
Pause. The importance of studying insect flight. We should all be tracking this paragraph. Either your hands should be on the desk. Our pages should be flat. We should be tracking our articles. Just like Nicholas, just like Jamila, just like Nayenda. Why is it important to study butterflies?
Fly!
Thank you. Why is it important to study butterfly what?
Fly!
Thank you. We're all reading together. Hands down, Callistus, this time. Because insect wing aerodynamics are not well understood. They're not well what?
Understood!
So that means we have to do additional research. Shania, you can put that down and just read along with this stuff. We have to do additional research as scientists to figure out how does movement occur. Gotcha. Continue. Nicholas, thank you.
Why?
Thank you.
The importance of studying. Why is it important to study butterflies? Because insects can fire aerodynamics.
Okay. This organization's going on. Wait. Our hands and start and our articles are flat right now. That's the expectation. So 2 people aren't there, 3 people aren't there, 4 people, 5, 6. 100% of us needs to be there. So Nicholas, you're going to start again in a loud and proud voice. Leave that there. Continue. Go.
Why is it important to study butterfly flights? Because insects' wing aerodynamics are not well understood. Figure out how small insects fly could allow engineers so when they build
Ultralight.
ultralight flying.
I said ultralight. You're going to say what?
Ultralight!
Flying robots to explore volcanic vents, get inside cracks on bridges or skyscrapers, or even explore other planets. We're going to look at the last quote, and then I'm going to give you some time in a second, Kareem. I know you're eager to talk. Hundreds of small robots could be lifted into space to probe planetary surfaces rather than lifting a single crawling robot. So pause. I'm looking for stuff. One of your challenges, or one of you, or maybe all of you, might decide to create a rover that picks up rocks on the moon. So our challenge at the end of this unit will be you creating a vehicle of your own design using these different maneuvering strategies of animals and other vehicles that we've read about. I need this. Tell me what you guys understood about that pulley weight system. Teach me. I need you all to teach me right now. First, I want to hear from Shadrach. We're tracking who?
Shadrach!
Let's go, Shad. So the more weight on an object, I'm looking for hands and star right now, because we're learning from each other. So Shadrach said, the more weight you apply on an object in a free-falling what?
Wisdom!
Let's try it again. The more weight that you apply on an object that's connected to your pulling system and your free-falling,
Wisdom!
the faster it goes,
Yes.
the object will go faster.
Yes.
So what if I put a book, thank you, Callistus, a book on top of a car that had a pulley system that had a great deal of weight. But what if the weight on top of the car, listen, your hand should be, what if the weight on top of the car was more than the weight pulling the car. Tell me about that. Callista's hand went up. Go.
What's the question?
What's the question? I'll ask the question again. What if in some crazy world, because your hands are weird? Thank you. In a crazy world, the weight pulling our vehicle was less than the weight on top of our vehicle. Chelsea, tell me what happens. What's going on? What's going to happen to the movement of the vehicle?
What's going to happen to the movement of the vehicle is that the vehicle will go faster.
It'll go faster with more weight on top of the vehicle and less weight pulling the vehicle? Sean, you seem like I don't...
No, I know.
No, that was your try. We're going to try Aiden. Let's go, Aiden. Oh, thank you. I have 1, 2, tracking 3, 4, 5. We're all there. Let's go.
I respectfully disagree with Callistus because if you add more weight onto the car, it's going to go slower because there's more weight on it and there's more mass.
Agree, disagree, have a discussion. Let's go. Agree, disagree, have a discussion. Shania.
I respectfully agree with you. In a car just had a book on top of it. That a book can't weigh more than the car, so it will go much faster than because the weight of the book isn't that much.
Great thought. Who's ready? Shall we start? Let's go. 3, 2, 1. First and last, when I say go, first and last name on your lab manual and your class. First and last name on your lab manual and your class. Go. When you're done, I need to see book baggies out, articles and book baggies, hands in star. I'm trying to get us down as quick as Miss Hackett does.
I told him that.
A lab manual?
Oh, yeah.
Yes, sir. Did you write your first and last name in class on your lab manual? I need you to get that done. Once you're done, you're going to put your articles inside of your... Thank you, Cheyenne. Thank you, Ayo. Put your book away. Okay, put your book away. Shatter book away. Book away, yeah.
Really good.
Book away. Put your book away. What about it?
I got it.
Yeah, but put this away now.
Yeah. You don't have to download it.
Look back. Let's see if we can do this quietly. Aiden, take your time. Hurry. No, grab some. Shania's there. So you have 10 seconds to have your book bags filled with your articles and see it. I'll give you 15, 14, 13, 12. Shanae's there. Your voice is off. Sit down. No. You're going to put your lab manual away. And that's not what you're doing right now, because I didn't give you that. Okay? Let's do follow directions. I'm waiting for 100% of you to have your hands in star. Pencils away, articles away. Put this in your book baggie. Your book baggie should be out. Let's follow directions, sir. Aiden, your pencil should be where? Thank you. You can just put that. Let's do it quickly. So I have Sean ready, Chelsea ready, Ariana's ready. I'm looking for everyone's eyes. You guys had a great class today. So I'm trying to get us downstairs within the next 2 minutes. That means we can easily go straight downstairs without stopping. Book baggie, It's up to you. Remember, this entire week, it's up to you. So I want you guys to do your stand-up procedure. Wait. As silent as possible. Alright, get ready. 3, 2, 1. Let's make it quieter. Nicholas and Sean, checks. 2. Nicholas and Sean, check. No speaking right now. Silently show me 3. That's what you just did? Okay. No, you don't stand this? Okay. Show me 4, everyone. It's up to you. No coats. Cheyenne, so sit with me in silence table, okay, today? Let's go.
No, Callistus.
Callistus, where do you belong, buddy? It's up to you.